Assalamu alaikum. Today, I want to present about structural analysis, which is one topic from statics engineering. There are a lot of problems in this world, and most of the time, engineers are the ones who solve them. Let's look at one simple example. Imagine a train carrying a very heavy load. It needs to cross a lake, different terrains, and long distances. So, what do engineers do? They design a railway bridge. But the important question is, how do engineers make sure the bridge is actually safe? To answer this, engineers use structural analysis. Okay, now let's say this is the structure that engineer want to build. From the analysis, we can know that the left side is the pin and the right side is the roller. And we also can know that the structure has three zero force member. Let's say we want to find the force members at FDF, FEF, and FEG. We can do method of section. How to do the method of section? So the first one, we need to draw the full body diagram at the full structure. Next, we need to do the equilibrium at the full structure. Third one, we need to remove the side that we don't want to use. And then lastly, we need to do equilibrium at the side that we choose. Let's look at the left side. So this is what real body diagram looks like. We have AX, AY, and LY. Okay, now I want to solve AY because I want to use the left side instead of right side. Since the left side is more easier to solve than the right side. We just need to solve the AY because AX is equal to 0, equal to sum of FX. Let's do the moment at joint L because we want to solve AY. So this is how I solve the AY and I get 138.83 kilonewton. Next step, we remove the right side and we keep the left side. Okay, we assume that all the forces are equal to tension. So FDF is tension, FEF is tension, and FEG is tension. So if the final answer is negative, it is actually compression. Last steps, what I do the moment at joint E. Why? Because every moment that approach joint E is equal to 0, so we can easily get FDF. So here we can see that FEF is equal to 0, FEG is equal to 0, and 95 kilonewton is equal to 0 moment. So this is how I solve the FDF. As we can see, the final answer for FDF is equal to negative 93.83 kilonewton. The final answer should be compression because it is negative. So the next step, what I do is sum of Fs. Here we can see that FDF, FEF, and FEG is Fs. So we have two unknown here, so we can't solve it yet. What we need to do? We need to do Fy. So we do Fy first, and we can get FEF. FEF is equal to 53.07 kilonewton. So it means it is tension since the final answer is positive. So this is equation 3. Then we can substitute the equation 3 into equation 2. So we can easily get FEG since FEG is negative 120.37. It means the answer is compression, not tension. This is the final answer after we did the method of section. As we can see that we have two compression and one tension. So I think that's all for me. Thank you.